Hello everyone, Bradley Sward here, and this video today is the 2022 Advent of Code Day 9 solution for part 2 of the problem otherwise known as rope bridge. And so the previous video performed part 1 where we have a head and a tail, and the head is moving around of a rope and the tail is following some rule set where it's like, okay, if it's cardinal direction for 2 or more squares, move closer. And if it's a little off, like a horse, like a knight from a chessboard, then move it in diagonally. And when we solve that problem for it's all the movement of those two pieces, we ended up with the value, at least for my data set, of 5,981. And now that's great for two pieces. So then now the next one becomes an arbitrary length where every knot along the way checks against the next knot instead of the first knot to see where it should move around to. And it's, it was a little tricky, took me a little while, of course, probably like a lot of other people will or have already tried to figure out. So the key was to make sure that now you set up just basically a list of different positions for the different parts of the rope, as opposed to just a head and a tail like I did for part 1. It kind of hard coded that. But now coming around here, what did I do here? Here's the same old stuff, but now I just called it head. I just kept the name head, but you can see now there are 10 pieces to this thing, and ultimately I'm still only keeping track of the tail, like the positions that the tail hits. So I still only need to keep one set going here, and all of this kind of keeps the same. But basically now what I'm doing, every time I make a move, I move the head one time over, and then I loop through all the other pieces, and then I follow the rule where instead of following like we did for part 1 where we check the piece against the head, this time around we just check the piece against the previous node, I guess, if you want to think of it, the previous knot in the chain instead of the first. And so you could see it's J versus J minus 1 and J versus J minus 1 to get the positioning. And then from there, we can kind of figure out if the numbers are, if it's left and down from where we need to be, then we move in the direction we have to go. And all of that code has stayed the same for the most part. And so at the end of the day, when I moved everything around one time, then I can check to see if that thing's already in my list and add it if I need to, otherwise move on to the next one. So it gets a little, as you can see, it's a little tricky. Let me see if I can get, there we go, one more time. See if we can get it all on one screen, kind of, right? Oh, let's do it one more time. Let's see. Oh, there it is, all tiny like. Can't get any better than that, I guess, for what we've got going for the code for this one. And again, pretty hard coded with how many different, at least 12 different if statements there. 1, 2, 3, 4, 5, 6. 10, 11, 12. 12 little if statements get us there, and I probably can fix that up as well. But it works. I have my solution, because my solution is, oh, it makes that tiny too down there. And it makes my solution, let's see, get closer there, 2,352 for my problem. 2,352 is the solution to the problem. It took me 3 tries. I had one that was too small and one that was too large. My values were 2,033 first, and then 2,443, and then my third pick was this 2,350. So that solves day 9 for the entirety of the problem. And as always, if you have any questions or know a better way, I'd love to hear about it. But this was a fun problem, as the other ones have been too. They're getting a little trickier. Who's not enjoying a little bit of trickiness? So thanks for sticking it out with me as always, everybody. Thanks for watching. And we'll see you for hopefully part 10 tomorrow.